Hi, scientists. Today we're going to look at a screencast about designing a lab investigation. So we're going to start off by looking at how to frame a hypothesis. Today's investigation is going to be looking at this research question. How does changing the potential difference that's applied to a circuit affect the current? So we're looking at the relationship between potential difference and current. You're going to use the PhET Virtual Circuits Lab to answer this research question by designing an investigation. And in this screencast, we're going to look specifically at how to frame your hypothesis. So let's take a look first at the rubric. The hypothesis falls under thinking. That's about inquiring and designing your investigation, so criterion B in the MYP. Let's zip down to the highest levels of the rubric to see what the descriptors are for performance. With a hypothesis, you want to formulate and explain a testable hypothesis using correct scientific reasoning. So what will that mean? Well, first of all, we're going to make a prediction. What do we expect is going to happen to current when we make changes to the potential difference? And secondly, we're going to explain it using correct scientific reasoning. The scientific reasoning that we have available to us is previous experience. You've done a number of simulations using the PhET Circuits Lab, and you can describe your experience in detail. That would be part of the scientific reasoning that you can use. Secondly, we have some formulas available to us that we can use to look at the relationship between potential difference, V, and current, I. You'll notice that both of these formulas contain the variable Q, which is charge. Because they have a common variable, we can substitute Q with one of the other variables. So rearrange this equation to solve for Q, and then use that to get rid of the Q over here. You should be able to figure out the formula that involves both V and I. So we can justify our reasoning mathematically. So those are two things I'd like to see in your hypothesis this time around. In the lab guide, we can use the lab guide as a checklist to go through and make sure that we are following and building our reporting according to our protocols. So we want to do a title that actually says what the investigation is about. So here's an example. This is an investigation of the relationship between the temperature of water and the rate at which an ice cube melts. Now, in this time around, I've given you the research question, so that's already provided. And we're going to look at hypothesis. So again, a hypothesis describes what you think the outcome will be. It specifically describes it in terms of changes to the independent variable and the effect that that's going to have on either measured or calculated variables, the dependent variable. And again, here's an example. If, and we'll use this phrasing, if, then. If the temperature of the water increases, then the rate at which the ice cube melts will increase. So how do you think that will be phrased when you're looking at potential difference and current? And then again, explain why you think this will occur. Make that prediction based on actual science, real-world research you've done, and your own intuition, and some math in this case. And you're going to put it right into the report template right here in hypothesis. All right, scientists, good luck with that.